LeetCode Problem 84, largest rectangle in histogram. Right, so the problem gives us an array of integer heights, and basically there are just a bunch of bar heights, and our job is to return the area of the largest rectangle that can be created from the histogram. Like for example, for this array of integers, the greatest one will be 10, right? Do keep in mind that the base can also be considered, but since this base is of area 8 only, so the largest is still 10 now, right? So yeah, see in this example, it shows that the base can also be uh, considered if it's if it's the largest area. So the approach I had to this problem was to use a stack to store the starting index of where it could starting index of where the height started, and the actual height of that index it started. So it can be quite complicated, but hopefully I can explain it well. I'm using a for loop to iterate through every number in the histogram, and yeah, so I have a variable called start here that I initialize to I. I'll be using start later on to save the value of where the starting position of that height could have been now, right? So since my stack is empty, I'll just push it, right? So I'll push the start, which is 0, and then the height I, right? Height I is 2. So this is what my stack looks like now. And then I increment I to start. So start becomes I. And now since my stack is not empty, I can begin checking whether or not the top of my stack, the height, is larger than the current height, right? But for this instance it is, right? Since 2 is more than 1, so we enter this while loop, right? So I have the variable top here to keep track of the top of the stack, right? So now our top looks like this, and now I compute the area, right? The area you had made, because the 2 here can't really extend forward anymore. So we know for the height, the area ends here, right? So the area is basically height, right? Top dot second, which is this, times the base, right? So in this case, the base is I is 1, 1 minus top first 0, right, where it started. So minus 0, so this will become 2, right? So now our largest is 2. I replace start with the top, which with the top first is 0, and then I pop this, right? So right now I then can push a new variable in that has start, which is 0, and then height I, right, which is 1, right? So what this means is now I have a height of 1 that starts at index 0, right? Because I have a height of 1 here that is still extending forward, right? Okay, next off I increment I again, so it's 2, and start is reinitialized to 2, and since my stack is not empty, so we check, right? And since 1 is not larger than 5, so I will just push, right? So let's push start 2 and 5. Okay, then increment start and I, and now we have 6, and since 5 is not more than 6, so we push as well. So this will be 3, 6, and then we increment, and now we are looking at 2, right? And now since 6, right, 6, the top of our stack, 6 is more than 2, which means from this point onwards, 6 cannot be pushed forward anymore, right? So the max height basically ends here, right? So we calculate the area, right? Replace top again, so top is 3 and 6. So the max will be top dot second, which is 6 times I is 4 minus top of 4 is 3, right? So this one is basically 6, right? So our largest is now 6. So we pop this, and since this is a while loop, then we check again, right? And since 5 is more than 1, and 5 is more than 2 again, so we have to repeat the same thing. So it becomes like this, and then we compute the area. So it will be top dot second, so it will be 5 times I is 4 minus top dot first is 2, right? So this is the 2, which in turn gives us 10. So now our largest is replaced once again with 10, right? So you can see the index starts at 2 and then it ends at I, right? So we have this big box here, and then we pop this, and then since 2 is more than 1, so we can't really do anything here but to push, right? Oh, before we push, remember that we update start, right? So since start is now top down first is 2, so it'll be 2, and then yes, and then only we push, right? So we're pushing 2 with 2. Yeah. So what this means once again is that here, from starting from this index 2, I have a height of 2 that can still be pushed forward, right? So the max height has not ended yet. I can this is to prepare for, yeah, not to prepare for anything, but this is just to indicate that a height of 2 that starts off from index 2 is basically is possible to compute the area down here. Moving on, we are looking at the last element, which is 5. Right, start gets reinitialized, and since 2 is lesser than 3, so we can't do much about it but to just push it. By pushing this again, so it will be 5 and 3, right? So right now our largest is 10, based only from our height alone only, right? So we have not considered the base yet, right? So there's a chance that there could be a max size down here, like a base, right? So to do that, for the rest of the stack, we will calculate from the size, right? From the back, right? Because for it to still stay at the stack means that the height has reached all the way to the end of the end of the array. So likewise, we have another variable top here, and then I replace it with 5 3, right? Remove this. So we compute the area. So this 5 3 comes from this, right? So 0 1 2 3 4 5, so it comes from this, and as a height of 3. So we compute, it will be 3 times size is the amount of integers in the array. So in this case it will be 6 minus 5, right? So this is 1 and this is 3, right? And since 3 is lesser than 10, we don't do anything. After that, we pop it, so this gets deleted, and now we replace it with 2 2, and we count again, right? So top second times 6 minus first is 2, right? So remember, this 2 comes from here, right? This 2 comes from here, from the start of the from index 2. So we calculate the size, this will be 8, right? Once again, since 8 is lesser than 10, so it won't be updated. and this will be popped. And for the last one, which is 0, 1, that started all the way from the beginning, right? So we compute, so it will be 1 times 6 minus 0. So basically this will give us a area of 6, right? So 1, 2, 3, 4, 5, 6, right? And since 6 is also less than 10, the largest stayed the same, and then we just return, right? So return 10. So that's how my algorithm works. That's all I have to show. Thanks.